So I'm just going to go over a simple way of a simple problem where I'm going to use voltage divider that has a really obvious answer, but I'm just going to use voltage divider to solve it anyway. So I'm going to have a network with just 3 resistors, V in, and I'm interested in getting the voltage across this resistor, V3. So the transfer function I'm interested in getting is actually V3 over V in. And this is what my G of S that I'm looking for is. Okay. So I'm just going to consider all the resistors to have a value of R, 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 and let's let R just equal 1 ohm, just for simplicity. Okay. So I can use, I pretty much can just say what the answer is. I know if this voltage is being divided across 3 resistors, then the voltage across the third resistor should be a third of what it is. So we can just sort of guess the answer, and we think the answer is going to be V3 over V in is equal to 1/3. Okay, so that's just going to be the ratio of V3 and V in. But what I'm going to do is I'm actually going to break this up in with voltage divider instead and just go through it that way. So I can break this up into 2 problems. Or break it out into 2 problems. So the first problem is going to be just the first resistance and then the other 2 resistances, just like I had before. But I'm going to lump these impedances together. So I'm going to call this impedance Z1, and I'm going to call these impedances Z2. Okay, and that's going to give me the voltage right here. I'll call this V12 because it's in between impedances 1 and impedance 2, or also resistor 1 and resistor 2 if I labeled them. Resistor 1, 2, 3, and all resistances are equal to 1 ohm. R1 equals R2 equals R3. Okay. So when I lump this out, I know, just using my voltage divider, I know that V12 is going to be equal to V in times Z2 over Z1 plus Z2. Okay, so that's going to give me V12. Okay, then I can break out the problem again where I'm actually starting with V12 instead. So starting with V12, I can have R2 and R3 in my network. And I'm considering this V out as equaling to V3. So now I can say that V3, or V out is equal to V3, which is equal to V12 times this, which I'm going to call Z3, and this, which I'm going to call Z23. I apologize for all the labeling. I just want to keep it as abstract as possible, but I'm going to substitute back in all these impedances. So I know that Z1 is equal to R1, and Z2 is actually equal to R2 plus R3. Z23 is actually equal to R2, and Z3 is equal to R3. So now that I've gone through that process, I know that V3 is equal to V12 times Z3 over Z23 plus Z3. Okay. So I can substitute this V12 back in. So I take this, which I'll call equation 1, and I'll take this, which I'll call equation 2. I substitute sub 2 into 1 to get V out is equal to V in times Z2 over Z1 plus Z2 times Z23 over Z23. Oh, sorry, this is not Z23, sorry. This is Z3. Z3 over Z23 plus Z3. Okay. So basically, I'm just using this voltage divider twice to give me this set of equations. So now I have V out over V in is multiplied by this set of impedances. And now I'll just plug back in for all these impedances. So Z2 is R2 plus R3. Z1 plus Z2 is R1 plus R2 plus R3. Z3 is equal to R3. And Z23 plus 3 is R2 plus R3. Multiplying those two things together, I just get cancellation of the numerator and the denominator, and I get R3. This is all times Vn. Times R3 over R1 plus R2 plus R3. Okay. So just like we said, we had this issue where we plug in the numbers 1 over 1 plus 1 plus 1 V in, which is going to equal V in over a third, which implies that V out over V in is equal to 1/3. Okay. This is pretty much the answer that we thought it was going to be from the beginning, but I just wanted to go through how you could step through voltage divider to give you the answer as well. I chose resistors because they're really easy to understand, and we sort of, that's the probably component we're most familiar with. But I could have chosen any impedance. These could have been in inductors or capacitors or resistors. No matter what, before I did this system, before I did this where I plugged in for the C1 equals R1, Z2 equals this, Z23 equals this, C3 equals this, before that I could have picked any impedance I want and still pulled out the answer.